Okay, we're back to example. So just now we learned how to find second moment of inertia, I equal to integrate r square dm, or I equal to so I equal to what? dm square. Okay. Now, if you're given this diagram, you have a density given, you have a thickness given, determine moment inertia of this axis, about an axis. So this basically is a two circle, big circle minus small circle, you get the second moment of inertia, right? Now, how to calculate moment inertia for the big one? So big circle is 250 mm, small circle is 125 mm. So how to calculate? You refer to this table. This shape is under this shape, circular disc, so you copy this one. You will see three equations given there. How do you know which one is correct one? You compare your diagram and the chart. Where is your G? Where is the G? Center. Look at the diagram. You come in from the same angle. If you view from here, you are seeing this one, right? You get circle and a G. So you view from top, you see G, and which axis you come from? Z axis. You come from Z axis, right? When you see this one. So Z axis, you have XX, YY, you have ZZ, Z prime. You are using this one because you come in from Z axis and from the G point. You look at the diagram. You want to do this one, right? How you get this view? How you get this view? Yeah, you're from the top and you see G, right? You go to the diagram. You try to think where you stand and then how you look from to get this view. You should view from the top here, right? And you see G. So which axis you are looking at from? Z. So from there you use ZZ. If you view from here, you see like a side thin there. Then you use ZZ or YY. It depends on where you look. So where you look is the axis that your eye is looking from. So in this case, you're looking from Z axis to get this big circle with the G at the center. Right? That's why we use I is exact half m r square. Again, all the parameter was given in the table. R, where is R? From the G to the outer circle. Here, what is the R? 250. Okay. You do the same for the small circle. Okay. So again, remember what is your I? Again, the one that you refer to the table or chart is only give you IG. It's not the final answer. So I equal to IG plus MD square. So you copy half MR square for IG and continue to write MD square. Okay. So you agree that our I equal to half MR square plus MD square. So we look at this and the whole. This is a this is a whole. So this one plus this one. Correct? A full circle plus a whole. Although it's a minus. Minus means you remove a solid. But if you look at whole, means right. So you just substitute how to find mass, density times volume. How to find mass, density, volume. You can find, right, volume. How to find volume? Pi r square times the thickness. All right. Just substitute the value, you'll get this one. Okay, I will not show you the detailed numbers. You go and press calculator and get this one. You do the same for the whole. Right, half mr square plus md square. You substitute, you get I for that one. Huh? The D. Where is the R? D is this one. Yeah, 250. Again, where is your D? What is D? Just now you asked me. What is D? Okay. Okay. Then total, you just substitute and then you get, so you take this one minus this one, you get 1.2 something. Okay, although I write plus, is actually you because you want to remove this one. So this second moment of inertia minus the whole. Okay. So you understand this one. Example 4 is a composite body that we mentioned. So you're given a pendulum, point A or O, consists of two thin rods. This one, OA and BC. So here you are given y prime, y dash, which is the average height refer to O, and you have all the parameter from the center, especially BC, center of A, 0.75, 0.75. How you find y prime? This one you learn in your static, right? Okay, so you're given the mass of each body. OA is 12, BC is 9. Determine moment of inertia pendulum about an axis passing through. The question asks you two things. One, you calculate moment of inertia passing through O. Then the second part, it asks you to calculate passing through G. Your moment inertia, it can change based on where you refer to. It's not a fixed answer. So here, this example 4, it shows you how to do calculation in point O, and another one is center G. So call the equation I equal to Ig plus md square. So part 1 means the one I highlight. Use table. What is this shape? Rod. Which one you're referring to? XX, YY, X prime, ZZ. Which one? Huh? Which one referring to? The first one, it asks you to what? Point O. You need to calculate moment inertia from point O. Where is the point O? Refer point O to the diagram. Where is your point O? Here. Not here. Here is where? G. The first part, it asks you to refer to O, not G. So refer to O. O is at the end of the rod. So you use X prime, Y prime for your IG. Make sense? Yeah. So your IO, moment inertia of rod OA about an axis perpendicular to the pitch and pass it through point O of the rod. So straight away, your point From point O, straight away from the table, 1/3 ml squared. What is L? The length. What is the length? 2. So you have IO, you substitute the mass was given, length was 2, you calculate, you get 16 kilogram meter squared. Again, unit is important. Then the same value you can get if you change to G point. If you're referring to the G point, if you use XX, YY, then you are actually getting the IG value here. You need to calculate your MD squared. This is the first set where you straight away you use X prime, Y prime value. Straight away your I equal to this one. Or if you want to go for a big round, long journey, also correct. No wrong. If you're looking at, if you use Y axis, X axis, but this one from G, so you need to calculate IG plus MD squared. Understand, huh? You want to give yourself more trouble, then go and pick G. So here, you substitute half ml squared plus md squared. Your L is 2. What is your D? D is 1 from here, from O. Okay, you get 16. Same answer as the previous one. Okay, again, it depends. If you want to do more work, then go and get the G. I will not go that way. I will use the shortcut. I look at the diagram. Endpoint, I just choose endpoint. Then straight away I get the IG, the I value. I don't need to calculate MD. Okay. The same concept. It doesn't matter with the shape. You look at the table. I don't know how you pass your static, but this one you surely know. You're referring to what shape you have. Depending on what axis you're referring to, you refer to the respective equation. Okay. So you have done for the first one, this OA, but this object have 2 components. You cannot stop there. You have to do BC. So what is BC? Okay. So what is BC? Also rod. You look at the diagram, from compare side by side. Which one is more suitable to use? Is this end? There's no end there. It's connected by the center, so you only can use G. Okay. So that's why in BC you use IXX, IYY, because it connected at the center here. That's why you pick G and not the end. Okay. So for rod BC, straight away you use IG equal to half ml square. What is the L? 0.75 times 2. What is the L? Here to here. Okay. Again, if you use this one G, you have to use back I plus IG plus MD squared. So here, you substitute for BG. Okay, substitute. You get the answer. Okay, again, what is D? Here to here. You're referring to here. The first section asks you from O. So for BC, your D is from O to the center of the rod. Answer is 2 here. Makes sense. Okay. So you need to combine 2 because we have 2 components. One is OA, one is BC. You combine, you get the answer. Okay. For part B, you are referring to G now and not O. Same, referring to table. But before that, you need to calculate what is the value of Y prime, or Y average of Y. This one is very familiar already. All right? Y average Y equal to the sum of Y individual component M divided by sum of the mass. Okay, this is to find the center of Y lah. I mean the average Y there. Okay, you substitute the value. For the first one, M, first one is 12, OA is 12. And then for this element, your Y is 1 because the total length is 2, average is 1. For BC, mass is 9, the length, this Y referring to here, so it's 2, divided by total mass. Okay, now if you don't understand this one, go back and find your static lecturer. Okay. So, same. You can use I equal to Ig plus Md square, same, but now you're referring to G. So, IO equal to 53.67, okay, equal to Ig. M total is 12 plus 9, 21. D is 1.4. You find the average Y here. Okay. So you get your Ig 10.8. Okay. So this is how you find out. Okay. Next one, we start to use equation of second moment inertia, go into motion. Again, for kinetic, what makes the thing move? What is the second Newton equation tell you? Force equal to ma. What does it mean? You must have what to create motion? What makes the acceleration? Yeah, what make the changing of acceleration? Force, huh? You must have force, then only have motion. The object cannot move by itself without forces. If you can prove that, then you are Nobel Prize winner lah. You are brighter than the genius that we have so far. You are discovering something new, right? Maybe there is, but that one is in quantum physics dimension. Okay. So when you look at equation of motion, you are familiar with this diagram already. With this, in chapter 6, you start to see center of gravity. And start from today onwards, your W, you should always draw along with your center of mass. Okay, so for your coming test 2 or final exam, if you see G point in your question, you shift your W, I give you wrong answer. Okay, draw something on the whiteboard. If you see question, give you a G point, and in your free body diagram, you draw something like that. You draw your W like that, I give you wrong answer. The correct one after rigid body was introduced to you when you do free body diagram, all the weight must pass through center of mass. Your W or mg must pass through center of mass. Take note, huh? Earlier, test 1, maybe you draw a little bit shift, I didn't care. But when it comes to your test 2 or final exam, you see G already, you draw something like this, you don't have any marks for your free body diagram. Because you don't understand what is the effect of center of mass. Then the rest is all the force. All these external force will convert to motion. You already introduced what is angular velocity. And you already introduced how to calculate angular acceleration. Okay. So by now, you should already know if your body rotate like that, you have a circular motion, you always have tangent and normal direction, acceleration. Of course, velocity will be in tangent direction. But both AT and AN, we have their own equation. Alpha T, both in alpha and omega. Alpha R and omega squared R. Yeah. Right. So by definition, okay, all this you read. This is just information. What we need to highlight here is that if you have force, all the force will create acceleration from the center of mass. Now, force equal to ma, you know. In chapter 6, rigid body, we focus on center of mass, which means that from chapter 6 onwards, your acceleration or in your kinematics diagram, your acceleration will pass through center of mass. If you recall, before chapter 1, 2, 3, chapter 1, 2, 3, 4, in your kinematic diagram, how you draw your kinematics, you just draw like that, right? A, V. In chapter 6, rigid body, if you draw this one, also wrong. Huh? If you still drawing like this, wrong. Huh? You need to draw like this, A, G. But of course, later you will see in free body diagram, what is your purpose of drawing free body diagram? You're focusing on forces. Acceleration is not forces. What is forces linked with acceleration? M. Meaning, in your free body diagram, you are converting acceleration as a product of mass. Mass multiplied by A, you get forces. So, your kinetic diagram in chapter 6 onward, you change the previous one into forces. Yes, this one, acceleration in this direction, but you change the acceleration multiplied by mass, it becomes forces. Ma is a force. Huh? Ma is a force. Huh? A alone is not force, but you multiply by mass, it becomes forces. Right. So you know that forces is a vector. Vector have direction and magnitude. You can break them into x and y, and also normal and tangent direction. It depends on the motion. If the motion in rectilinear or straight line, then you can do x and y. Or in the question, it gives you xy direction, axis, then you use xy. If you see the object in the question, it rotates as a rigid body. When the object rotates, it means it moves in a circular motion. Circular motion gives you tangent and normal direction. It means your F equal to ma also change into normal and tangent direction. Okay. So I will skip all this. I already explained all this in the whiteboard. So from today onwards, chapter 6 onwards, we have two sets of diagram, free body diagram with all the force only, and kinematic diagram or kinetic diagram, which is you only see forces in MA and no longer A inside the kinetic diagram. This is the conversion or when you study rigid body. Okay, if you particles, then because particles is one dot, the mass is very, very small. So it doesn't matter you write MA or M, it's still very, very small, right? But when a rigid body, then the mass will take into effect. Then you need to always remember in your kinetic diagram, you are using moment, you are using mass multiplied by A. Okay. Then later, with free body diagram and kinetic diagram, because forces with the distance, you get moment. Right. Again, what is moment? F times D. So if you're given distance for free body diagram, you can get all the moment from free body diagram to equal to all the moment from kinetic diagram. Make sense? Moment over here will equal to all the moment over here. Okay, so later you will see one more not new, but new presentation of answer. All the moment in free body diagram equal to all the moment in kinetic diagram. You write this one, and then this one refer to your free body diagram, free body diagram and kinetic diagram. Again, how do you find moment, force, and D? This is a vector. Vector you can break into x direction, y direction. Don't say, hey, sir, I cannot know. I don't know how to find this one. The arrow have it's not a right angle. I don't know how to do. Remember, you can split this one into x and y direction. If it's x, then the forces will turn, the moment will turn clockwise. Then the y component will turn anti-clockwise. We have two moments if you split the vector into two. And my practice, I will always, in default, I will use anti-clockwise moment as positive. But again, it depends on the question. The direction of this object, I will always follow the body omega or alpha direction. Why? Because I want to get positive in my answer. Yeah, that is my practice. By default, it's anti-clockwise. But if I look at the question, the object rotate clockwise or anti-clockwise, then my moment will be clockwise positive. Again, yeah, it's a good practice that we fix one rotation or one moment direction. Okay. The rest I already explained. The rest you read. Okay. The rest you read. All these are mathematics derivation. At the end, you arrive at this equation. Okay. All the moment you link with acceleration, angular acceleration, you use back Ig at the center of gravity times the angular acceleration at the center of G. You get moment of the P, moment from point P. And P means from one reference point. Okay, same. So For second half, you have one new equation to memorize, with how you link angular acceleration and second moment of inertia I, convert it into moment. When you take Ig multiply by alpha, you get your moment at a certain point, from a certain point. Okay, because before this, in your statics, you only learn about force. F equal to Fd, you get moment. But dynamic, you start to learn about angular velocity, angular acceleration. Then you combine Ig and angular acceleration, alpha, you get moment. Okay. Again, how to find Ig? From where? From table, huh? Don't say, hey, sir, I don't know how to do it. I don't memorize. You don't need to memorize. Ig is from the table. Okay. The rest you read. Again, I, it depends on where you refer to. If you refer to center of gravity, you need to calculate md square. I equal to Ig plus md square. If you're referring to G, there's a distance that you need to calculate from a reference point. Okay, so how do you find D? If you refer to this diagram, how do you find the D? The D will be, this is the D. So you take x square, y square, square root, you get this D. Okay, again, D is from your reference point, the distance from your reference point, in this case from P. Okay, then here, I alpha. Again, what is I alpha? Moment. The previous one also moment. MA is what? Force. Force times D, you get moment. Okay. So just to simplify everything, the rest you read, because I don't want to confuse you. The rest you read, Important, I did write on the whiteboard. The rest is just derivation. You simplify until you get this equation. But still the same like I write on the whiteboard. All the moment from free body diagram. This one from kinetic diagram. Again, what is kinetic diagram? After chapter 6, you convert all your acceleration, multiply by mass, put inside on the central of mass G point there. Become a force. Once they become a force and distance will create moment. That's why on the right hand side, they are moment plus angular acceleration moment. So you have two for rigid body. You have the effect of forces from the center of gravity because of mass, and also moment because of your angular velocity acceleration. So for rigid body, you need to consider alpha and MAG. Yeah. Okay, this is the one that I write on the whiteboard. The rest you read. So again, you have a rectilinear translation and so on. Still, if you look at the diagram, you have two kind of diagram. On the left, always free body diagram. On the right will be kinetic diagram. So don't worry about all these things. As long as you remember free body diagram, you're interested in forces only. And from the forces, the diagram, beside it help you to find F equal to ma equation, it will help you to find moment equation. Chapter 6, you need two. One is the forces, F equal to ma, and another one is moment equation. Moment from the free body diagram equal to moment from the kinetic diagram. From the kinetic diagram, always change your acceleration multiply by mass become forces. Okay? Forces multiply by perpendicular distance, you get moment. And again, direction by default is anti-clockwise positive for moment. Again, it depends on the question. Because I want to get positive calculation, I will follow the object rotation. Okay, so this is the one that I keep repeating. So if it's in rectilinear, at the center of G, right? If you refer to G, what is the moment from G? mg, no, from G. Moment over here. 0, Why 0? Distance equal to 0, There's no 0 there. There's no distance from G. That's why mg 0. Then F equal to ma, this one you familiar already. Okay. Then what else? Okay, if this one was moved in the straight line, means no rotation. No rotation means no omega, no alpha. So what happened to your moment? Ig alpha equal 0. No rotation if it's moved in a straight line. Make sense, huh? So for this, you read, so still same. We're still repeating m equal to m kinetic. Yeah. Curlinear. Curlinear, you do remember curlinear, there's a rotation already. So rotation, you have moment no longer 0, but you need to use Ig alpha. Same, still same. Try to observe what is the difference between chapter 1 until chapter 5 and chapter 6. Particle rigid bodies is different on the kinetic diagram, where you combine mass and acceleration become forces, right? So curlinear, again, curlinear, you have tangent direction and normal direction for your acceleration. Okay, MAT along the motion, around the curve, N is to the center of the curve. Right. What else I need to? Okay, then there's an equation that link AG or acceleration in tangent with omega and alpha. So you need to memorize that one. Same with normal, Okay. The rest is still same. Okay. The rest is still same. It's still repeating the same thing, Okay. So if you have an object towed by a truck, this boat with on a wheel, are you able to convert the scenario in the picture in the free body diagram? Right? So same. First, you draw field of the diagram. Again, center of mass. Look for G. G, and then again, your W always from the G point. From the center of mass, again, don't draw your W away from this dot. Because you're in chapter 6 already. All right. Then all the contact will have one contact force, A and B, and then there's a towing force. Of course, if the question gives you friction, so you have friction force in A and B. Depends on the question. Okay. So kinetic diagram, free body diagram on the top will equal to kinetic diagram. Again, kinetic diagram, you combine acceleration with the mass in chapter 6. become forces to where? So it depends on the direction of moving. To the right. So your forces will point to the right because of your acceleration direction. Okay. Again, ask yourself, what is the purpose of converting your acceleration and mass into forces? Because in chapter 6, you have one more equation to consider moment. To find what? To find contact forces or the missing parameter. Because you have more than 3 unknowns in chapter 6. You have more and more unknown. So you need more equation to solve. So here we introduce you one more equation, which is the moment. Moment over here will equal to moment over here. And again, by default, anti-clockwise moment positive, but again, it depends on how the object moves. But you still get the same answer. Okay, so again, if you take the moment at G, some moment at G, you'll get 0. So it will be equilibrium. So you put your hand here. So this one will create clockwise, this one create anti-clockwise, this one will create anti-clockwise also. Okay, here will create clockwise. Okay, let's look at this example, then we call it a day. Example 5. How you know you are in chapter 6 question? You will see G point already. In previous one, you won't see G point, but we see G point means you need to use equation M in the calculation, right? I'll give you 2 solutions. So you are given a car with a G and a dimension here, right? The height and the distance between A and B. Mass was given. Determine acceleration of the real driving wheels that always slipping, where the front wheel is free to rotate. What I mean by free to rotate? It means no contact forces anymore. No, not contact, no friction. Okay, no friction. Ignore the mass of the wheel and the friction was given. How to convert this one into free body diagram? What are the first force you put in your free body diagram? Weight at where? G. Then contact force, contact force. Okay. Okay. Then contact force. All right. So why the front wheel don't have the friction force? It's because it tell you it's free to rotate, so no friction force. Right. Any what? Separate what? Separate tires. You need to look at the question. Some question it will tell you to calculate friction force of each wheel. Then you need to look at the vehicle, how many wheels you have. This one don't mention to find forces at each wheel. So you only consider front and back. Okay. No, you don't confuse with the principle still same. Any contact surface will give you N. What is the object you see in the previous chapter? Flat surface. So only one. If you see wheel, all the wheel have one contact point. These have 2 wheels, 4 wheels. Yeah. Yeah. Okay. It depends also on the question. So previous one, it asks you the contact forces of the wheel, and that one is particles. Particle, you only have one dot. You rigid body, you have to consider all the contact surface already. So here you have 2 wheels, technically have 4 wheels. But this one is you only consider front wheel and back wheel. So you have 2 contact. unless the question further mention the car have 4 wheels. Calculate the contact forces for each of the wheel. Then, in your free body diagram, 2 and A, 2 and B. If the question mentioned 4 wheels, and you need to find the contact forces for each wheel, or friction for the each wheel, then you need to put 2 there. Okay. Now, why FB this direction? Why your friction force this direction and not the normal direction? How the wheel turn? So you're opposite of the wheel direction. So it's pointing this way and not the chapter 1 until chapter 5 direction. Again, chapter 5, previous example, you only have one contact surface. So you see the whole thing as one. Then you look at the motion as one. But here, you are looking at rigid body. You need to be particular in that. Okay, so any question on the free body diagram? Then I give you kinetic diagram. Kinetic diagram, again, what is the difference? The forces, the acceleration multiplied by mass change into action. Same, Okay, equation 1, you use the 3. This one is translation. Translation, your G translation moment is 0. Okay. Put in there, and then you put in there. You solve for the unknown. This is method number 1. Method number 2, you use the moment equation. The G, MA, and you use moment equation. Okay. Same, So there's one, I think, one mistake here. This is don't have 0.3, because forces. There's a typo error on my slides. Okay. So example 5, you have 2 methods. Again, when you need to use moment equation, when the previous equation cannot help you, right? Or you have more than 3 unknown, then you use moment. Okay. All right. We stop here. Again, there's a typo on my slides. This is not point. You have to cancel this one. No 0.3. Okay. Okay. Next lecture, we look at this example. Okay.
So when do you know the